So two videos, we're going back to back. The second video will be doing some interval stuff, critical points, max, mins, concavity. But we're going to start with the function above. We're going to prove the mean value theorem on an interval. We think of the mean value theorem, that means the instantaneous rate of change, f prime of c, is equal to the average rate of change over the interval. Again, to really simplify this, I don't know what this curve looks like. It's x cubed. I suppose I can figure out the values because I'm going to need them anyway. I plug in -2 into the function. I get 10. I get 10 minus 6. I get 4. So this point is -2, 4. I plug in 2. -6, 6. I think I get 0 when I plug 2 in. I get 8 minus 8. Yep. What it's saying, and I don't know what this curve looks like. I really don't. I know it's going to go through 0, 2. So I figure it's part of the polynomial curve, you know what I mean? Well, it's looking like that or something. But what it's saying is that the blue line is the average rate of change between those 2 points. And somewhere in the point, there's going to be a point C where this purple tangent line, which I completely missed the curve on, there, is going to equal the same slope as the blue line. That's what's happening here, all right? I don't need a graph to do this, all right, but that's what it is. So I have to find f prime of c. F prime of x, in this case, I think it's a pretty easy one. You guys agree? 3 minus 3x squared. And so I would put c in equals f of b minus f of a. And again, the reason I did this is if f of -2 is 4. We figured out that f of 2 was 0. So I'm going to go 4 minus 0 over -2 minus 2. And it makes sense looking at the graph. That's negative. In fact, it's -1. All right, I'll bring the 1 over here. I'll bring the -3c. 4 equals 3c squared. And I get 4/3 equals c squared. Take the square root. I get plus or minus 2 over the square root of 3. All right, and when I think about this, I think it's both answers this time. I think it's both answers. They are both within the interval of -2. So I would say c is equal to those two values. I immediately know my little sketch cannot possibly be even close to right. Graph it or not. Let's pause the video and get a graph up here because now I'm curious. All right, so there it is, the picture of the graph. And again, I'm going to put the red dots here. 2, 6, boom, 2, 0, -2, 6, 2, 0, right there. All right. Yeah, I should have known it's 2 things. It's x cubed. You're right. There's the average. And then, can you guys see it? It happens at -2 over the square root of 3, which is 2 divided by 1.7. So about 1.1. So somewhere about here. Okay. And then at -1.1, which is somewhere about there. Can you guys see those two values? Those are the two c values. So it works. We've proven the mean value theorem for this problem. I'll go to the entire page. And a nice little problem to show mean value theorem. Again, instantaneous rate of change equals average rate of change. Don't detect